Good evening, everybody. Welcome to SuperCollider lecture stream week 10. Let's do a quick sound check. Hey, Pierre. Looks good, sounds good on my end. Pink noise, making noise for all of you. Thank you, N. Parmore. Appreciate it. Okay. Well, I'm really excited about the topic tonight. This is one of my favorites. I think this is what helps make SuperCollider really shine as a language for synthesis and the things you can do with it. So we're going to talk about OSC. OSC stands for Open Sound Control Protocol. It's a specification for communication between computers and other devices, devices which are optimized for modern networking technology. Hey, Infinite Monkeys. Staying up just for this. Wow. Awesome. Great to hear it. Let me grab Firefox real quick. You can go to opensoundcontrol.org where you can read about the introduction to OSC, Open Sound Control Protocol for communication among computers, sound synthesizers, blah, 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 optimized for modern networking technology. So I probably sound like a broken record to my students who've heard me say this before, but OSC in some ways is like MIDI, but way better. MIDI, we're stuck on a, most of the data that gets passed through MIDI is 7-bit, which means there's only 128 discrete values that you can use, with a few exceptions, but that's basically how MIDI works. So it's not a very high resolution protocol, and it's inherently wired. It's non-trivial. I mean, it's not a standard thing to send MIDI wirelessly, and it runs at a specific rate. But Open Sound Control is faster. It's more accurate. You can send floats. You can send really any kind of data you want, and you can do it wirelessly. So it's really a really fancy thing. And SuperCollider is entirely built on the OSC protocol. Actually, the language sclang and the server, SC Synth, both of these applications are OSC compliant, and they actually use the OSC protocol to talk to each other. So when you say something like synth.new, what actually happens is the language sends an OSC message to the server, which tells the server to, hey, make a sound, instantiate this synth. So it's really, really cool. I have a tutorial. It's tutorial 11 on my channel here, so this is something worth watching. I'm gonna cover some of the same stuff that you see in this video, but as always, these videos are sort of more compact and to the point. But I'm gonna do some things that aren't in that tutorial video in the live stream tonight. The basic plan is we're gonna use TouchOSC, which is running on my iPad over here. And I think, let's see, I still have my live capture. Yes, we do. Yeah, so I've got TouchOSC running. We're gonna, let's see, we'll back out of that for a second and we'll hide that. We're gonna use TouchOSC to send OSC to SuperCollider. So basically using this we're gonna design a very simple control surface and then use it to make messages and make a very simple sound. But that's not all we're gonna do. We're also going to explicitly send an OSC message from the language to the server, and also from the server back to the language. And then finally, I also have a second computer down here, and I'm going to pop this open and basically type code and evaluate code on this computer, but cause my main computer to make sound. So it should be a fun night. Hopefully we'll get through all of it, and hopefully it makes sense. All right. So a little bit more about OSC and how it works. Basically, to send OSC from one device to another, be it iPad, computer, whatever, the sending device needs to know the IP address and network port that the receiving device has and is listening to. And OSC messages always follow a particular syntax. They start with a URL address style string. Like, your message might be the string test. And we know symbols, strings, they're interchangeable in SuperCollider for the most part. But, when we make synthdefs, we give them a name, and then we add them, do all this stuff here. And this backslash is how we delineate a symbol. But I think we can't actually, like, if, the OSC address tags that OSC messages always start with /, and I think SuperCollider doesn't like this syntax. We try to delineate the symbol /test with a backslash. As you can see, it doesn't actually turn green, so it has some problem with that. But there's an alternate style of specifying a symbol, which is just enclosing it in single quotes. So double quotes, that turns gray, that's a string. Single quotes, it's a symbol. Although I think in a lot of cases you can use either one. In the OSC context, I think it actually doesn't care. All right, so you need to know the IP address and port, and then you just need to be able to send and receive OSC data. Oh, and then the last thing before we actually get into it, there's a document called OSC communication. And this is a useful introduction of just, it's not very long, and it just gives you a basic SuperCollider syntax orientation for sending and receiving OSC. Very handy thing to read. Doc, please. Thank you. Okay, let's get into TouchOSC. So I've got TouchOSC down here. I'm going to open it up, and we're looking at the sort of settings page here. And if I go to this layout menu sort of in the middle, a bunch of I assume everyone has or is going to download TouchOSC on their iPhone or mobile phone or whatever, iPhone, iPad, whatever. And then there's also the TouchOSC editor, which we'll get into in just a bit. So this is the app itself that runs on your mobile device, and there's a bunch of pre-existing layouts, some of which come bundled with TouchOSC, and others like Basic and EEF 2014. These are ones that I've made that just live here. So I'm just gonna grab. I guess we'll just go with. Automat is already selected. We're just gonna choose it again. We could choose something else if we wanted, like Beat Machine. So that's the current layout, and if we just tap Done in the upper right-hand corner, now we've got, it's a multi-touch sort of thing. You can touch multiple things, whatever. We have some sliders over here. We have toggle buttons. They can be on, they can be off. And then these are a bunch of momentary buttons. They're only on as long as you're pressing them. And this one comes with several pages that you can tab through. I have some knobs. So these don't do anything right now. Just because I'm not receiving the OSC data that it's sending. So let's just jump back. You can, when you're done with where are we? Hold on. Done. Yeah, okay. So when you're done playing around and you want to, change the settings of TouchOSC, as you'll probably need to do, you want to tap this little dot in the upper right corner. That takes you back here. So we'll go into the very top where it says Connections OSC. We're going to tap OSC. And here we have our OSC settings. And you first of all want to make sure that your OSC communication is enabled. That's sort of a no-brainer. And then there's host. This is the IP address of the host device. And this is my computer's IP address. This is the IP address of the computer that TouchOSC is going to be sending data to. So what I've done ahead of time is I've just gone into my network preferences here, and under Wi-Fi, I mean, this is how you do it on Mac. I assume if you're on Windows or Linux, you know how to check your IP address. So I've just copied that down, 10.192.192.241, and you just simply touch here and enter your IP address. So I already have it here. And then there is port, outgoing. This is the port that the host computer is listening to for OSC. And there's lots of OSC programs out there, not just SuperCollider's OSC, lots of programs are OSC, and they all have some sort of default port that they listen to for incoming OSC data. And remember, from week 1, SuperCollider is actually 2 programs. It's the SC Lang, the language, the interpreter, all the code, and then SC Synth, which is the synthesis engine. And these are 2 separate programs. Now, in tutorial 11, I'm not exactly clear on this. I should have been more specific, but I'll set the record straight here. The language listens for OSC on 57120. The server listens for OSC on 57110. So right now we have TouchOSC configured for sending to the language, and that's what we're going to do. We're going to receive OSC messages in SC Lang. Okay, so then we have port incoming. This is only relevant if you want to use your computer to send OSC messages to your iPad, to like update its state or something. There are many cases where you'd want to have OSC going back and forth, but for right now, we're just going to be sending from the iPad to the computer. So this can stay at 9,000. We're not even going to use it. And then the last one is I can't actually edit it because it's the IP address of my iPad itself. So that's just, it is what it is. You need to know that if you're going to set up your laptop for sending OSC to your iPad. So that's the basic step. Enable OSC communication, enter the IP address of the computer that you want to receive OSC, and if you're sending to the SuperCollider language, make sure the port is set to 57120. And then we just go back here, and that's configuring TouchOSC. So now what we're going to do is, instead of using Beat Machine or one of these pre-existing layouts, we're going to make our own layout. And the way we do that is not in the TouchOSC app itself. It's actually not possible to edit or create layouts in the app. So instead, we use the TouchOSC editor. This is a free download that you can get on the Hexler TouchOSC site. So it's going to open it right up. I think it's going to pop up on my other monitor. Yes, it did. So here it is. This is the TouchOSC editor. So we're going to build a really simple interface, and then we're going to sync it. We're going to sync our computer with the iPad so that the iPad updates itself with the new list of layouts. All right, so first of all, I'm going to choose iPad because that's what I'm using. So it gives me an iPad proportioned canvas. And then we're going to zoom down to 75, maybe 50%, just so we can sort of see everything. And I have my iPad horizontal, so we're going to pick a horizontal, horizontal layout. Come on. Thank you. Okay. Oh, there we go. So how's everybody doing so far? Is everybody with me? You can still hear me, following along? Let me know if you have any questions. Okay, so we have a blank canvas. Now it's up to you, right? So you're the creator of whatever interface you want. So whatever project you're working on, maybe you need some buttons, maybe you need some faders. Anyway, whatever you need, just right click or control click on the canvas, and it gives you this list of GUI objects that TouchOSC has. So we have push button, toggle button, an XY pad. Some of these I've used the multi-push, multi-toggle a few times to get like a grid of stuff, and I haven't really practiced with those. I'm afraid I might sort of goof that up. But let's make a toggle button, and we have a little toggle. We can drag it around. We can resize it. I think if we hold Shift, it maintains its proportions. and we can change its color to whatever we want. All right, so there's a button. Let's right click again. Let's make a vertical fader. Actually, okay, because this is an interesting quirk of TouchOSC editors, that if you make the orientation horizontal, then basically everything is sort of flipped. So this is a horizontal fader. It's vertical to us, but it's because the layout is horizontal. This horizontal slider appears as vertical. So we will just put this here. Maybe we'll make a big fat fader that we can easily manipulate. And maybe just for fun, we'll make a what is it? A rotary? That's what they call knobs in TouchOSC. So I think I want to do, yeah, horizontal to make it behave sensibly. So, all right. So there we go. We can't actually, touch and manipulate these. This is just the editor. So then when you're done, you want to save your layout, and it's going to ask you to save it as something. So I'm going to call this OSC _ lecture. And you want to make sure that you save this in the layouts folder that comes with the install of TouchOSC editor. So on my computer, in applications, I have TouchOSC editor somewhere down in the T's. And in this folder, there's the actual editor application itself and a folder called layouts. This is where you want to save your layout. So we're going to hit save. And now we've saved it. And now to get it onto the iPad, we need to sync these devices. And we've already made sure that the iPad's on the same network. And we know that it's got the correct host IP address. So we are going to sync this. And when we click sync, a window pops up. And it says to sync the current layout to your device, make sure they're on the same Wi-Fi network. I did already check that. They're both on the, on, what is it, Illinois net. They're both on the same network. That's important. And then over on TouchOSC, we go to layout and choose add, and then select the machine's name from the list. So let's go do that. So we're back in TouchOSC, and we go to layout. And then at the very top, this bar, it says add. So we're going to click add. All right, and this happens sometimes. Sometimes, I think usually like on your home network or something, your device will sort of just pop up automatically. If it doesn't, you can enter the IP address manually. So that's what I'm going to do here. Yeah, it's nice when it pops up automatically. You just click it and then it just syncs automatically. So we're going to go to edit in the upper right, and then we're going to go to the plus, which appears in the upper left. And now I just need to enter the IP address of my computer, which is this. So we're going to hit done, and then the editor host appears. Then we click that, and now hopefully, yes, here it is. So we have added OSC lecture as a new layout, and then we're just going to click done. Ta-da! There we go. So now we can actually play with it. Wonderful. I'm glad that worked. I mean, it usually works, but with wireless stuff, sometimes stuff doesn't happen. Okay, so that is a big important step out of the way. We have a layout. It's got a button that we can turn on and off. We've got a fader, and we've got a knob. And it's wonderful. It's multi-touch, so we can do two things at once. That's one of the big appeals of TouchOSC is multi-touch. Takes advantage of multi-touch surfaces. All right. So now I think what I'm going to do is make this float on top, so it's always on top. We are actually done with TouchOSC editor, so I'm just going to quit that. And now I think we'll give ourselves a little bit of space here and put this here. So now, there we go. I think that's okay. Whoa! Come back. Just rearrange stuff here. Hopefully that's not too small for everyone. It's still working, still live. Wonderful. All right. So TouchOSC, in fact, when we move these, you can see it's very small. I'll make this bigger briefly. in the upper right of the TouchOSC, as we move a slider, we see a little green LED come on, right? On, on, on. What that LED means is that TouchOSC is sending an OSC message. So that is good. And there's an LED below it that is red, and the red comes on if TouchOSC receives an OSC message. So that green LED is a good sign. That's what you want to see. All right. So let me just check my notes here, make sure I'm doing this in the right order. Since we're sending to the language, I think we don't actually have to boot the server. We could, but the language is up and running, and it's capable of receiving OSC. So that's what we're going to do. You will recall, I hope, from the MIDI lecture, which was it's all blurring together, either 1 or 2 weeks ago. There's an object called MIDI def, and I actually have my MIDI controller here, and it's plugged in. So just as a refresher for the syntax here, we're going to do MIDI in.connectAll. And there we go. We have our nano control mididef.cc. Give it a symbolic name to store in a global dictionary in SuperCollider, and then we pass in, you know, value and number, and we'll say value num.postln, and then we just evaluate this MIDI def, and all of a sudden, let's bring this up here, right? Then we've got MIDI boop 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 boop. Boop, boop, boop. Just like that. Data flows right in, and postln is a good place to start. OSC works in very much the same way. Free all. Let's see. Good. There's no OSC def.connectAll or anything like that. All we have to do is just make an OSC def. And there's no CC. CC is a MIDI thing, you know, note on, note off, whatever. We just say OSC def.new. And again, we give it a name. You know, this is how SuperCollider keeps track of various OSC defs. It stores it in a dictionary according to this symbol, so test. And then we create a function to be evaluated when an OSC message is received. And we declare an argument here, message. And let's look at the help file for OSC def. OSC def. So, right, OSC def.new, there is a key, the key at which to store this OSCD. OSCD. I'm mixing OSC and SCD file. Wonderful. A function. The function is the second thing. A function, and it will be passed the arguments message, time, address, and receive port. Why don't we just go ahead and declare those? Again, these don't have to be named exactly as you see them here. You can name them whatever you want, but it's important to remember that the first argument you declare corresponds to the OSC message itself, then time received, and then address and port. So as I always like to do, oh, okay, we're not quite done, right? There's last we need to, I think this is necessary. We want to provide a symbol indicating the path of the OSC address of this object. So we actually need to go back to TouchOSC editor for a second. I forgot about this. TouchOSC editor. And let's take a look at, let's open a recent thing here. Move this away for a second. Open OSC lecture. And let's click on our button, for example. And now I want to bring your attention to, let's see, I want to make sure I'm not obscuring anything. Over here, the auto box is checked, which is fine, which means TouchOSC automatically generates OSC addresses for the messages that these objects are going to produce. And the address happens to be /1/toggle1. This one is /1/fader1, and our rotary is /1/rotary1. You can uncheck auto and name these whatever you want. The only requirement is that it has to start with a /. So I'm just going to memorize these, burn these into my brain for a second. We have /1/toggle1, /1/1fader1, /1 rotary1. Okay, we'll just hide that. Bring this back. So the third argument is a symbol. We're going to use single quotes, and it's going to be /1/toggle1. Okay, and I think this is all we need. So we should be able to evaluate this and then touch the button over here. Yes! Yes, it worked. So that is exactly what we want to see. And it's a pretty verbose thing when you post all of the data that comes in for an OSC def. You can see the first thing we have is the message itself, which is an array containing the address followed by the data associated with that address. In this case, it's just a button. So it's just 1 or 0, right? 0 when it's off, 1 when it's on. I don't think you guys are appreciating the gravity of the situation here. And we've got it. Look, it's wireless. It's Wi-Fi communication. It's fantastic. And then we have the time at which the message is received, which is sometimes useful. An instance of net address and a port, and then finally so basically all this stuff here is kind of confusing to look at. So first of all, let's just not post everything and instead just post the message. And the great thing about OSC def is that if you want to overwrite one of them, same thing with MIDI def and synth def, they all are stored at this global key. And if you just reevaluate it, it gets overwritten. So now instead of seeing the entire collection of data, we just have the message itself. Yeah. So you guys out there, it's awfully quiet tonight. I don't know if you guys are following along or just, doing what, but anyway, I hope you guys are having a good time and this is making sense here. Okay, and then if we want to get even simpler, we can just say message. Remember, this message coming in is an array, and we can say, just give me the data, please. Just give me the item at index 1. The item at index 0 is the URL style address of the message, and message at 1 is the next thing. In this case, it happens to be the value of the button. So boop, boop. That's nice and clean, right? We just see the button data. Thank you. Thank you. I appreciate the feedback. And I'm not trying to get everyone to just be constantly chattering away, but when there's like radio silence, sometimes I'm like, oh, my stream is probably dead, and I'm just talking to myself here in my office late at night. So, okay. Let's quickly get the I'm gonna free this test. I'm gonna give it a more meaningful name. So I think now I should have nothing. Yeah. So we're sending OSC, but now SuperCollider is not receiving it anymore. I'm gonna call this button. There we go. So we've got our data back. Let's make another one. I'm just going to copy and paste this just so I'm not, typing it all over again. We're going to call this one fader, and the address for that is /1/fader1. And again, this is going to be just an address and then a value, but it's going to look a little different, obviously. So now let's just see, we still have our button. And now here's our fader. Whoop, there we go. Just what I wanted to see. So loading point values. Boop, boop. You can tap to change it instantaneously. And you can scroll it this way and that. And then finally, let's do the knob, which is going to be a lot like the fader. Really, one is linear, one is rotary. That's really the only difference. The address here is rotary. I like to call them knobs. And there we go. Our knob is working, our fader is working, and our button is working. That's really all we need, and now it's up to us here to make sound. So we will. I noticed I had the server booted this whole time. I think it would have worked if the server had not been booted. Anyway, What we're going to do now is make a simple synth def. We'll make it just a simple tone. Freak arg freak equals 440. Make a signal and an envelope. We'll do a lovely triangle wave. Envelope. We're going to do an ADSR envelope. Maybe just an ASR envelope. Good to know. Thank you, Chethonophan. Yeah, I figured it would. I think I actually tested that earlier and found that it worked. I think this is just left over from my pink noise sound check. Oh, cool. That's good to know, Pierre. Just I mean, this TouchOSC is not the only app out there. I mean, I've also got an app called Lemur, which is very much the same sort of thing. That one of the biggest differences with Lemur is that you can actually edit and create entirely in-app, so there's no desktop component that you need to download. And there's a lot of fun objects here. It's like physics intelligent and knows how you're touching it and stuff like that. So Lemur is more expensive, but TouchOSC definitely gets the job done. It's a good bang for your buck. So let's see, attack time, sustain time. These are all fine. We're just gonna make a gate and done action 2. We'll make an amplitude argument as well. And actually it doesn't really matter. We're gonna and then we'll make it stereo. Nope, we don't play synth defs, we add them. We're gonna test this out real quick. Amp, let's see, gate. Yeah, this is all fine. Okay, so that's working. What we're gonna do now is just change some of these OSC dev functions. Oh, thanks, Cloudfon. Appreciate it. All right, let's make the button turn the sound on and off. Let's have the fader control the amplitude, and let's have the knob control the frequency. I don't know. This is really simple stuff, but it's good to keep it simple at first. So the button, we can have it still post its value, and we're gonna say if message at 1 is 1, x equals synth.new. Sorry, it's called tone. And otherwise, x.set gate 0. And the fader is just simply going to say x.set amp message at 1. And the slider goes from 0 to 1, and 1 is full amplitude. So I think I'm just going to like divide this by 4. So that the maximum amplitude is actually 0.25. And the knob is going to say x.set freak message at 1. And of course the range, the 0 to 1 is not suitable in this case. So we'll do linexp from 0 to 1 onto 250 to 1500. And this is sloppy, right? There's going to be some problems with this, but let's just do a basic sort of test here. I think we're good to go. And this has some of the same problems that we encountered with MIDI. For example, if we try to move the fader or the knob, we get this because it's not checking whether the synth exists. It's just trying to set a value. But because we turned the button off, done action 2 freed the synth, and so it's gone. So one option is to either create a group that is permanent and then just set the group with the knob and the fader. or we can register the synth and then do conditional logic here to make sure the synth is playing before attempting to set it. And another problem is that, you know, if I move the knob and then turn the hit the button, it doesn't give us the right frequency. So what we should do here is for the knob, also have the function, you know, update a global variable, you know, message at one.linexp whatever, and then when we instantiate the synth, do this, you know, actually create the synth with an initial frequency value corresponding to the position of the knob. So, but you know, I'm not going to bother with all that because you've seen the basic concepts in the MIDI video, and this is stuff that I think, you know, it's good to figure out on your own, clever solutions to making this work. But this is the basic idea. We've got TouchOSC, we've made a simple interface, we've set the IP address and port correctly, and then we just, on the other end, we configure SuperCollider to be listening for the correct addresses. And data just flows in, and it's all of a sudden we have a custom multi-touch controller. That's the end of that segment of that lecture. We're gonna now sort of put TouchOSC away. I think I want to have you guys all do a take-home assignment on TouchOSC, and you'll send me your layout that you create, and you're gonna go into where are my layouts, applications, TouchOSC, like whatever layout you create, you know, you will attach this or compress this with your SCD file as a zip file, and then I will sync my computer with all your layouts and test it out myself. That's what I'm leaning towards anyway, something like that. All right, let's get that out of here, and let's clear all this stuff out. We're gonna do osc def.freeall and start fresh. Okay, moving on. As I mentioned at the beginning, sclang and scSynth are two separate programs, and they are both OSC compatible. And when we do something like this, what actually happens is the language, synth is sort of a convenience for the user. It's a language-side representation of a server object. And when we run x equals synth.tone, in the background, an OSC message is generated and sent from the language to the server. And when we do x.set, we actually generate an OSC message and send it to the server. And so there's no real reason you'd want to actually get into the nitty-gritty of sending OSC as an explicit message with an address and all the arguments and stuff, because you have the synth and group objects to just, you know, do it manually. Also, when we add a synth def, that's also an OSC message. Anything that involves the server is an OSC message. That's how the server communicates. The only way to access the server is to send it OSC messages, and this is a convenience for doing that. It's pretty cool. However, I do want to briefly talk about how we would manually generate an OSC message and send it to the server, keeping in mind that there's never really any need to do this. There's a file called server command reference, which I am of the opinion this could be improved. I don't think it's that useful. But basically, it's a list of all of the OSC commands that the server understands. So there's, you know, quit, for example, notify, status, command. But then there's a whole bunch down here that are specific for synth defs, nodes, you know, synths and groups and stuff. For example, here's a command. Remember in TouchOSC, the address tag was /1/ you know, toggle1. And here, the command we'd need to send to free a node is /n_free. So same syntax, different message. And then there is, you know, there's a whole bunch of stuff. We care about this one, s.new, or not s.new, /s_new. So if we wanted to send create a node on the server, a new synth, and we wanted to do it this way instead of the convenient way of using the synth, what we'd do is we'd say, you know, server.local, or just, of course, s, which is, you know, a convenient shortcut for accessing the local server, .send message. and we're gonna say the server s.send message, and we're gonna go to the help file for send message and go to the server. And here is an example of sending an OSC message to the server. So we're gonna start, and in here you see it has double quotes. I've always done single quotes, and I think single quotes work fine. So this is an OSC address. That's the beginning of a command that tells the server to make a new synth. The next one is a symbol for the name of the synth dev. And then we need to, what's the next one? Oh, a node ID, right. So if you look really closely on the node tree here, it says group 1. The node ID of the default group is 1. And if we run this, let me turn the amplitude down a little bit so we can hear ourselves. Yeah, the node ID here is 1004. And when we do synth.new, node IDs are generated automatically for us, and it's really convenient that we don't have to manage node IDs ourselves. And as a rule, you can't have two nodes with the same node ID. That's not allowed. If you try to add a new synth or a group and say, give it this node ID, but that already exists on the server, it's going to say duplicate node ID. You can't do it. So it's really annoying to have to do this yourself. So I'm just going to give it the arbitrary node ID 2345. I think you can go all the way up into 5-digit numbers. I'm not exactly sure the highest number you can use, but the server starts with 1,000 and then just sort of counts up. And that's all I really know. Let's go back to command reference. Server command reference. So the synth definition name, the synth ID or node ID, and then an add action, which we specify as an integer, 0, 1, 2, or 3. 0 is add to the head of the target. 1 is add to the tail. 2 is add it before the target. 3 is after. And 4, replace the target node. So we're going to do, I'm just going to do 0 for add to the head. And then we provide the node ID for the target. And I'm just going to provide 1, which corresponds to the default group. So this is going to add a new node. It's a synth using the tone synth def. It's going to have node ID 2345. It's going to be added to the head of the node with group ID, with node ID 1. So this is the default group. So this should work. And before I run this, I'm going to get a command ready to free it, which is n.free node. No, I keep saying dot because I say dot all the time in SuperCollider, but it is n_free. And I think here we just need to provide the node ID of the node we want to free. So, and we didn't even we just freed it. We didn't even set its gate. I think we could do that using the where is it? There's got to be a set command. Is it n.set? I think it's near the top. Yeah, n_set. I'm gonna guess. See, this is not really. I can't really quite make sense of this, so it's always a little confusing. But I'm gonna try n_set, and then a node ID 2345. Oh, I need a thing there. 2345. I'm gonna try gate 0. That's what I'm gonna try. Okay, yeah, so that worked. And we can also just free it abruptly. So here we're doing the exact same thing as this, except we're not providing a default amplitude. Does the same thing. The difference is that here we have to, manage the node IDs ourselves, and we can't, maybe we can use a symbol add action, add to head, whatever here. But anyway, this is the under the hood way of doing it. I just thought I'd show that just because it's kind of interesting. This send message does come up if you want to send from one computer to another. So we will, I think, come back to that at some point. But Anyway, it's much more interesting and useful to get the server to send OSC back to the client. This is really useful for a number of things, one of which is making level meters. So what's actually going on here is that when we open the level meters, the SuperCollider creates a node at the top and a node at the bottom, which basically monitors the signal coming in. It measures its level and then sends OSC back to the language and uses that data to update these graphical sliders. So that's actually what's going on. There's OSC coming back to the language here, but we're gonna do it ourselves. And the way I'm gonna do it is I'm gonna make a synth that plays like sinusoidally fluctuating brown noise, just like ocean waves. It's gonna be very soothing. And then we're gonna get the server to track its amplitude and then send the amplitude back to the client. And then we're gonna like use it to move a fader. Yeah, okay. So let's first make a synth dev. We'll call it ocean. And we'll have a signal, which will be stereo brown noise, 0.2 amplitude, and an amplitude modulator, which will be a sine wave, which can be a control rate sine wave. We'll have it be 0.2 hertz. The initial phase will be 3 pi over 2. This makes the sine wave start at its lowest point, so we actually sort of fade in. And then we also need to say, give it a suitable range. Yeah, 0, almost 0 to 1. And then we'll say sig equals sig times mod out 0 sig. So nothing new here. Regular old stuff. Let's play it. I think that's a little too extreme in amplitude. Make it a little faster, maybe. Oh, you know, I liked it better the other way. And then, you know, just for fun, let's do, put some reverb on it, even though there's no reverb at the beach. That's silly. Sig 205, and we'll scale the reverb down quite a bit. Okay. Very nice. Okay, so this synth does not actually send any OSC back to the language, but the way we get the server to send OSC back to the language is using, surprise, surprise, a UGen. There is a UGen which is used specifically for generating OSC messages and sending them to any registered clients. We'll talk about what that means briefly. So that UGen is called send reply. Send an array of values from the server to all notified. Yeah, I said registered. I meant notified. Notified clients. Now, when you're working on the local server so that the SCLang and SCSynth are on the same machine, whenever you boot the server, you automatically become a notified client. And I think if you're working on another computer and you're connecting to you work on your computer and then somebody else's computer has the server, I think all you need to do is send a message to the server that just says notify, 1, and that tells the server, hey, there's a new client who wants to be notified when you do stuff. And so then send reply will also send OSC messages back to that client as well. So all you have to do is tell the server, hey, notify me, or I want to be on this list. But you don't have to do that if you're working on the local server because you're automatically a notified client. Anyway, we need to, we just simply go down here, anywhere really, as long as it's after this line, because this line is a direct representation of the amplitude of the signal. It's an amplitude modulator, right? It's being multiplied by our sound source. So mod is the signal we care about. So just down here, anywhere really, as long as it's not, I think you could probably even put it after the out, but somewhere after mod is defined, we say send reply dot kr is fine. Trig, the first argument is trig. It is basically whenever send reply gets a trigger here, that's its cue to make an OSC message and send it off. So what I usually do here is just use impulse. Rates have to match, has to be KR, KR, or AR, AR. And impulse just generates triggers at a particular frequency, and we'll just do 20 per second. 20 is probably enough. You know, you can think of this as like movie frame rates, so like 30 frames a second, or you don't need 1,000 triggers per second. That's kind of ridiculous. You just need enough that you can get the value. And then command name. You can think of this as simply the OSC address that is tagged with this message. And for that, we're just going to say ocean amp, end symbol. And then finally, the third thing, so we have trigger, we have command name, and then values. And in this case, we just want the one value. I think we could provide an array. Yeah, you can provide an array of UGens. So if we had more things we wanted to track with OSC, we could put an array here. But instead, we just want to do mod. And that is it. It won't sound any different. Nothing special is going to happen here. But now, what's happening is as this synth plays, it is sending OSC back to the language. So the last thing we have to do is just make an OSC def. We'll call it track ocean, whatever you want to call it. This first symbol is not really that important. It's however you want to organize your OSC defs. Arg message, and we'll say message .postln. This is going to give us an array containing ocean amp, the symbol, and then the value. And we close the function, and then finally tell it which address to listen for, which is the address we defined in the UGen here. So I'm going to start the sound, and as it's playing, I'll just start this OSC def, and we will see all of a sudden data just flowing in to the post window 20 times a second. So here we go. And here we go. It's a beautiful thing. Yeah, there's a few more. I should call this X or something so I can, Yeah. So if we free this synth, that frees everything in here. This unit generator graph function, which includes send reply, is gone. It leaves the server, and so as a result, we stop getting OSC messages back. This OSC def is still live. It's just that nothing's being sent on Ocean Amp anymore. So we could just make the sound again, and data starts right up again. And there's a bit more data than I originally anticipated if we post the full message. It is the address of the OSC message, what I assume is the node ID. This one here, I think that's if we, reply ID. So if we put like a 1 here instead, we're going to get a 1. Yeah. It's basically, send reply lets us also add an integer ID. I think it has to be an integer, right? Reply ID. Yeah, an integer ID. Just in case you want to also include a number here. So yeah, this is the node ID of the node that is sending, that has the send reply in it, that's sending the OSC. An address, node ID, whatever ID we tagged it with, and then the actual value of the signal itself. So we can change message to message at 3. And now we'll just see the value. Okay, now the last thing we're going to do to add on to our GUI fun, we are going to make a slider. And we're going to have it monitor the amplitude. So the fader is going to be like ghostly moving up and down in sync with the brown noise amplitude. It's going to be awesome. We'll say rect just 10, 20, 20, 20, 200. Nice long vertical slider. Yeah, I'm gonna have this float on top. And I'm going to change the bounds so that it actually shows up on my second monitor. I think it's like something like this. Hey, there we go. Just so I don't have to be constantly dragging it up. Make it a little smaller. I'm going to try to drop it on top of the help documentation so it's not really in our way. I can do better than that. 11. All right, good enough. All right, so we can move this slider. Doesn't do anything. We are going to change this OSC def to say slider dot value message at 3. And we don't have to do any mapping here because our modulator signal goes from 0.001 to 1. And our slider goes from 0 to 1. So we can just, as is, drop this float value into the slider.value. And this is not going to work. I'm pretty sure it's not going to work. I know why, but I just want to do it this way anyway. So we'll do this. And then we're going to reevaluate this. Yeah, okay. Whoa! Okay, command period. By the way, command period by default will also free any OSC defs unless you use the permanent method and set them to be true. OSC defs are not permanent by default. That's false. So if you press command period, they'll go away. And I kind of like that. I kind of like command period being our fail-safe, like stop everything, kill everything. So, but if you do want to make it survive command period, you can say .permanent _ false. Sorry, true. True. The reason we were let's see if we can just generate a few of those messages again. Okay. What is it telling us? Aha. We've seen this before last week, I think. Qt, error Qt. You cannot use this Qt functionality in the current thread. Try scheduling on app clock instead. So what's happening here is that this OSC def, this is inherently scheduled in some way, and it's running on a process that's governed by either system clock or tempo clock, and you are not allowed to get or set GUI objects or Qt GUI stuff with one of those clocks. You have to use app clock instead. So if you're doing a routine, you can say routine.play parentheses app clock. But we're not doing a routine here, so the alternative is to put this part of the code in curly brackets and say .defer. And this is like a convenience for making a little mini routine that plays on the app clock. So this should work. And so now we'll start the sound. Actually, we'll go ahead and start the OSC def. And then as soon as we play the sound, I believe we should see this fader move up and down by itself. Oh, so nice. It's great. These are the moments I live for. Yeah, it is, Pierre. That's for sure. There's also send trig, but send reply is always, it's really the only option I know of for like being very specific about what you want to send from the server. So now, usually the server just sits there waiting for OSC commands to come in, and it makes sound, makes a synth, makes a group, whatever, all that sort of stuff. Here, we've actually got it actively sending stuff back out. It's saying, hey, here's the amplitude for this thing I'm doing, right? 20 times a second, it gets a new value, and our slider just moves by itself. If we do these and try to touch the slider, we'll be like fighting with it, I think. Like we can't, we don't have total control over it. It's like two processes are updating it at the same time. So this might be a good reason to do .enabled false. So now it's moving, but we cannot interact with it. Only the server can. Yeah. Okay. How's everybody doing? There's one last segment I want to do. We'll get to it in just a second. Just want to check in with everybody. You guys are following reasonably well enough. Hope this is all making sense. Okay, the last thing I want to do is pop open this computer here. And what I'm going to do is use this computer to send OSC. The first thing I'm going to do is I'm going to type code here and send OSC to the language on this computer, right? The one whose screen is being displayed up here, right? So computer, sending computer, receiving computer, all right? And we're going to send to sclang first, and then we're going to send to scSynth. And that's really cool. I love sending straight to the server on another computer, because you type code and then another computer makes the sound. It's so cool. I just absolutely love it. Okay. Now, I don't have this screen on the stream, so I'm just going to, I have sort of prepared the code. So the code that I put on the sending computer, I will also put on screen up here for all to see. But just keep in mind that, in this configuration, the sending code goes on a different machine. I'm just putting it here so everyone can sort of see it. Okay. So the first thing we need to know on the receiving computer, well, on the receiving computer, we're just going to make an OSC def. We're just going to say OSC def. If we're going to receive in the language, we make a new OSC def. And we'll call this, receive or something. Arg message, message.postln. And we need, there needs to be agreement with the sender and the receiver with what OSC address, URL style address is going to be used. So you need to be in agreement. You can't just, you need to know. You got to know the address. So we'll call this test ADDR, test address. And boom, we're ready. We're listening. We are listening for any messages that come in on /test address. And now on this computer, let me get this up and running. What you need to do on the sending computer is create a new instance. So this is, let's just receiving computer. There we go. Sending computer. Well, first of all, you need to know the IP address and port, the IP address of the receiving computer, and you need to know what port it's listening on. And we know those things, right? We know my IP address, and we know that the language listens on port 57120. So we're going to create on the sending computer an instance of a class called netAddress. This is similar in a lot of ways to the server class, except the server refers to an instance of a server, an scSynth program. NetAddress is a little bit more general. It just represents a computer or a device on a network as specified by an IP address and a port. It's a really, really simple class. It's very, very useful for wireless communication. So the IP address has to be a string and the port has to be an integer. So on the sending computer, it looks like n, I'm just going to say n as a global variable, net address.new, was it 10, 192.192.241, and then the port 57120. So I'm not going to evaluate this here because, this is just so you can see, but I do have it over here on this computer. And I've made my net address. And then on the sending computer, we send a message to this net address. And the syntax here is the address, right? Just like it was in TouchOSC, just like it was coming from send reply back to the language. The first part of an OSC message is the URL style address. So this is test address. And then whatever we want. It's our message. We can send whatever we want. It's not like MIDI where it has to be a value between 0 and 127. Let's send the number 1, the string hello, and then I don't know, the number 200. Right? So that's what I'll send from this computer here. What is it? 1, the string hello, and the number, what was it, 200. All right. And so now I'm going to run this code on the sending computer. I've already evaluated my OSC def on the receiving computer. So when I run this, we should just see this message show up in the post window. Yes. And yeah, so we can send it again and again and again. And I can change this code however I want. I can, the third number, I'm going to use, I'm changing the third number so that it's rrand, 100 to 900, for instance. So now that third one is a random number. And then we can get, we can have our OSC def here say signosc.ar message at 3, right? Because it's 0, 1, 2, 3. 0, 0.2, exclaim 2 times x line 1, 0.01, done action 2. Just a very, very simple synthesis function. Or just make a little sine wave with the frequency. I've updated that. And now if I send from this computer, and I feel like I need to be sort of a magician here and pass this laptop through a hula hoop to show you that there are no wires connected, right? Ooh, it's magic, right? So here it is. I'm evaluating code. All right. On this computer. Oh, look at this. But the synths are showing up. Make these a little bit longer on the other computer. Make it a full 1 second decay. Yes. So I think the theory is that you all at home could make my server start making sound. I think if you, I don't think we need to be on the same network anyway. So I think that's theoretically possible. You can just jam with somebody around the world if you know their IP address and their port and what kind of OSC addresses they're listening for. So that's really cool. That is OSC from one computer to SC lang on another computer. And then basically the receiving computer is relaying that data and passing, an OSC message to the server running on this own computer, so SC lang to SC lang, and then SC lang to SC synth, and we have sound. So totally cool. And the last thing I want to do, man, we blew through this lecture. I thought it was going to be at least 10 o'clock by now, but I think this is going pretty well. The last thing I want to do is send OSC directly from the language on one computer straight to the server on another computer. And this is really cool. You can actually load synth defs onto somebody else's computer, and you can send, synth.new stuff straight to their computer. So so this is right, from one computer to SC lang on another. Now here we're going to do from one computer to SC synth on another. Now the server is running, right? It's all the receiving computer has to do is this, right? So we can quit the server, whatever, boot the server, and we're ready. The server is listening for OSC messages. They just have to have the right addresses on them. So that's all. So now what we're going to do is on the sending computer, create a synthDef. And the synthDef that I am creating, let's see if I can just copy and paste it here, is, it's just, again, I'm keeping it really simple. Sending computer, we say synthDef.new, it's called blip. It is a sine wave multiplied by an X line object. I'll make it a little bit, we'll just keep it as is. The difference here is that we do not, on the sending computer, we don't say .add because that adds it to the server locally. So instead, what we need to do is define a new instance of server, right? Normally we just say, oh, server.local or just S, great. Here we're gonna say remote server equals server.new. Server.new. We have not seen this yet. Making a new server. Now we give it a name, whatever you want is fine here. And then we give it an instance. Let's go to the server help file. The server.new, here it is. A name, a symbol, whatever, address, an optional instance of net address providing host and port. We need this in this case. So it's going to be net address.new and then 10.192.192.241, comma 57110, right? Because the server listens for OSC on port 57110. The language listens on 57120. I think it's possible to change these ports, but I just always go with the defaults because there's nothing wrong with the default values. It's it's totally fine. So we know the server is by default listening on this port, and that's all we need. So this is, again, the sending computer over here. So I'm going to run that line, and I've done it. And now I'm going to say, instead of .add, .send, and then in parentheses, remote server. So send this synthDef to the server specified by this server instance. So it's on somebody else's computer. I'm going to do that. I don't know if we're going to see anything. Yeah, on this computer it says warning server remote not running, but that's not true, and I've gotten that message a couple of times and I think it's harmless. So I don't know, we'll see. We'll see. And then finally, we're going to say synth.new blip. We'll say freak exparand 200 to 2000. And then the target is how we tell this synth where to go. The target goes to remote server. And we have some options here. I mean, we can also create groups on the remote server and send it to that group. If we specify a server as a target, it goes to the default group of that server. So I'm going to now run this line on the sending computer, and hopefully it will work. Yeah, it works. I'm going to change the, I've changed the decay time of the envelope. Yep, so here is our client computer over here. And it is sending OSC straight to the server on another computer, on this computer right here. Incredible. Yeah, so this is going to be the focus of the in-class problem sets tomorrow. I'm going to just show up with my laptop. I'm going to boot my server and make some OSC defs and post my IP address on screen. And you are all going to define a synthDef and then play it. And we're going to have like a little experimental improvisatory class jam session. It's going to be cool. Man, so this is what I was talking about when I was saying, this really makes SuperCollider shine. I mean, other software does this as well. It just seems really slick in SuperCollider, where you can just any number of clients, any number of servers, as long as you know your IP addresses and port numbers. There's a lot you can do. It's really, really cool. Oh, Pierre, I did not know that. I see you got a bunch of messages from you here. Ah, okay. Right. I do know that the IP address 127.0.0.1 is a reference to your own computer. So you can define a net address that corresponds to your own computer. And I have seen the 255 before. I did not know that's what it meant, though. That's good to know. So if you make a net address with that IP address, it broadcasts to all devices on that network. Cool. Yeah, that is really useful. I guess the alternative would be keeping an array of net addresses and then collecting over them and sending it to each one. Yeah, I don't know how that would. I mean, I wonder sort of what would happen because I'm on this humongous university network right now. But sure, certainly on a home server or something small or a dedicated router, that'd be pretty useful. Thank you for the tip. I appreciate it. So that's it for week 10. That's OSC in a nutshell. I hope this has been an enjoyable session for everybody. Yeah, I mean, it only took us 75 minutes or so. I guess that's what happens when I actually prepare for my lectures. Yeah, I went through all this like yesterday, just making sure everything was working. There's a lot of moving parts here. You know, we got the TouchOSC here, going through QuickTime. You know, that's still running. Yeah, okay. Anybody have any questions? Yeah, something else we can do. If we go back here, you know, we could say, you know, make a nice no questions from Zia. I like it when students don't have questions. It means I explained something reasonably well. So if I do something like this, you know, on my, I guess I gotta type this on my other computer now. And we can sort of make a little sequence. Cool. Questions tomorrow are fine as well. I just want to make this crazy loop here, because why not? All right, so we're gonna play this routine. Yeah, and now my server is just helplessly receiving all these commands from other computers. Yeah, I could make a you know, pattern. Like and then we can say p.next. Let's do that over here. Oh, whoops. What I meant to do was this. Right, not all of the integers between those. That would take forever. That's what I wanted. I'm really impressed with the latency. It seems really steady. When I was at home, it was kind of not very rhythmic at all. It was yeah. Oh, it skipped a little bit, but anyway, that's not bad. Yeah, latency is like the biggest sort of issue with network synthesis, stuff like that. General question. Yeah. Okay. Any strategy using SuperCollider in more of a free improvised setting as opposed to composing pieces ahead of time? Sam actually has a pretty. I've seen his setup. He's got like a GUI and everything. I mean, he improvises, but he built a quite a substantial code architecture ahead of time. You know, so he didn't compose the piece ahead of time. I've seen one of his pieces as well. Last time I checked in with Sam, he has a Manta controller, which is this really fancy, funky controller, and then he's just got like some sort of GUI and code architecture where he can just add stuff and take stuff away dynamically. It's just live coding, you know, one way or another. And lots of people do this. And it's sort of a philosophical question too. You know, it's like, what is the right way to do live coding? Are you supposed to start with this and like for 10 minutes or so just build your synth defs while everyone watches in silence? I mean, I would say no. I mean, you should come to the table, come to the, you know, the stage with some sort of infrastructure that you have developed ahead of time. And in doing so, created an environment in which you, the performer, have options that you can decide on the fly. I think that's the way to do it. You know, you don't have to compose the whole thing ahead of time, but I think you have to sort of have a plan. Yeah, I mean, I think there are probably very few people who show up to a live coding gig and have nothing. I would guess that the majority of those people come with some big clump of code that they, you know, just run to initialize everything, and then maybe they'll start doing like, you know, little ideas here. One of the lecture topics I have planned, I think it's like the last stream this semester, is an introduction to live coding. And to be fair, I don't really know that much about live coding. I don't do a lot of live coding, but I do know that there's a bunch of classes like NDEF and PDEF and PBindEF and TDEF and all these def classes, which are really meant for live coding because you can overwrite them on the fly and change them on the fly, and you don't have to like free a synth, and then, you know, it's all, you can do a lot of very nice crossfading and yeah. So I hope that answers your question. You know, there is I see if I can find it. There's a video of James Harkins doing some live coding. There's lots of live coding videos. Yeah, I think this is it. This is the one I saw. He posted this on the SuperCollider listserv a while ago. But and he's got a pretty custom syntax that he's developed for himself. Like, this is not normal looking SuperCollider code. I mean, in one sense it is, but it's very specific to his the way he works. I'm not even really sure what he's doing here with these pipes and periods and stuff. I guess he's specifying rhythms and patterns and stuff. But it's all been reduced to a very simple syntax that's very intuitive for him. Anyway, it's fun to see what he does. And if you want to do live coding, you know, SuperCollider is great for that, but there's other options as well. Like there's you know, Sonic Pi is something I want to get into and actually start teaching. It uses the SuperCollider synthesis engine in the, you know, behind the scenes, but there's a lot of hotkeys that are really meant for you using just the keyboard as your instrument, and like you don't touch the mouse at all, you know. So Yeah, it's kind of like that. You design your instrument, and maybe you leave a few pieces missing that you can dynamically add to your instrument or take away. You know, kind of like how performers will like take the mouthpiece off their instrument, like improvisers, and they'll like put a different kind of mouthpiece on it and flip the instrument around and start stuffing things into it, and you know, just kind of messing around. You've got the instrument. You don't have to go up onto the stage and like build the instrument from scratch and then start playing it. You come with something to the table. That's my philosophy. I think I'm not the only one that shares that philosophy. But I can imagine there are some purists out there who think differently about it. Yeah, so this is just on James Harkin's channel. I think it's a pretty good jam. It's maybe not sort of instructive to look at the code, but maybe instructive just to get a sense of what live coding looks like to a performer. Anyway, I'll let you guys listen to that on your own time if you want. All right. So I think I'm gonna wrap up here. I'll see everyone taking the 499C class in class tomorrow. I know some people are gonna be out for various reasons, so you're gonna miss some fun stuff, but you'll find a way to get to it, I'm sure. And then a TouchOSC take-home assignment, which I'm gonna try to keep fairly simple, just because I know the final projects are on, and I don't want to distract you too much from those. But it should be a fun class tomorrow. So thanks everybody for watching. And yeah, guess that about does it for tonight. Okay. See y'all later.